Okay, this is experiment number 13 here. What we have is a 100 millifarad capacitor, which is hooked up to a loose wire on the positive end, and then on the negative end hooked up to a 3.3 kilo ohm resistor, which is then hooked up to these two LEDs, which it's difficult to see. So if you look over here, these LEDs are in this orientation, so that one is reverse biased, depending no matter which way the current flows. And then that LED circuit is then hooked up to the ground via this wire, which is then the grounding circuit has a loose wire attached to it as well. So what we're going to do is take our power source here and attach it to the loose wire on the positive side of the capacitor, and you saw that the right LED, which is forward biased in this case, light up, but then it quickly diminished as the capacitor fully charged. Now the positive end of the capacitor is fully charged, the negative end of the capacitor has no charge to it. So what we need to do is connect the ground to the positive end and then let the positive end drain out of all voltage. And then what we're going to see is that the right LED, which is now forward biased, it was reverse biased, now it is forward biased, is going to allow electrons to flow back to the negative side of the capacitor. So by connecting the ground wire, we see that the left side LED lit up, allowing the capacitor to discharge. So now we're going to charge the capacitor. Charge the capacitor. We saw. No, it didn't fall. Charge the capacitor. The right side LED lit up. Now we're going to discharge the capacitor. Left side LED lights up. Charging it, which goes very quickly, and then discharging it, which takes much longer because the discharge time has to first go through the 3.3 kilo ohm resistor versus the charge time, which is directly linked to your power source here.